We've hit second matrix. We've added. We put in matrix A. It was a 2 by 3, and then we typed in all of those elements. We hit second mode to go back to the regular calculator screen and get out of that matrix. Press second matrix again. And then I'm going to go to edit and pick matrix B. Put in that 2 by 3 matrix. Type in the elements for that. And then get out of that, go back to the regular calculator screen. Second mode again. And then we want to go back to the matrix. And here's where we're going to pick them up to use them. And that's where the names part of that menu is. We're going to pick up and use matrix A plus matrix B. So I'm going to, under names, I'm going to hit enter for matrix A. I'm going to hit a plus sign for addition. And then second matrix 2 for B. And hit enter. And we get the same matrix back that we got by doing it by hand. See why I don't do that in the calculator? It takes flipping forever. A lot of work for something you should be able to just do. Adding and subtracting numbers. That is the drawback to matrix on the calculator. It takes a while to type them in. If it's a really large matrix and there's a lot of individual pieces and things, it might be worth the time to type it in there because you could misadd or something along the way if you've got a whole lot of elements to put together. But for something this small, I'd do it by, without the calculator probably. Just, or do the individual elements if I had to have that for the calculator instead of typing in each matrix. Subtraction works the same way. So if we took the same two matrices, let's say we had 3, draw that big enough, 3, -5, 6, 4, -2, 11, and then we subtracted off -2 or -12, 6, -4, 10, -8, 4. Subtracting those two, it's the same rules. Dimensions have to be the same to add or subtract. If the dimensions aren't the same, we can't add and subtract them. Okay, these do match. It's a 2-row by 3 column, 2-row by 3 column. That matches. Subtract the matching pieces. 3 minus -12, 15. -5 minus 6, -11. 6 minus -4, +10. 4 minus 10, -6. -2 minus -8, +6. 11 minus 4, 7. 2 by 3 minus a 2 by 3 gets us a 2 by 3. 2 rows by 3 columns. It's just matching pieces. 3 minus -12. Each piece matches up. So easy to do without the calculator. Since we already have those two typed in, we could check that really easily by just picking up matrix A minus matrix B, because those are the exact same ones we used there. We see that we did do that correctly. Okay. All right. Now, look at example C before we depart from adding and subtracting. Go to something a little more interesting. Let's say we had 3, 4, 5, 6, 7, 8. That's our matrix. And we were subtracting -8, -9, -10, -11. Creative example here. Can we do that? Why not? They're not the same size. We got a 2-row by 3 column here. We got a 2 by 2 here. They don't match dimensions, so we call that undefined. That's what you would say. If you tried to do that with your calculator, it would give you a dimension mismatch error, which is exactly what that is. It's that the dimensions do not match. So I would, you can look at that and say, oh, I know 2 by 3 and a 2 by 2 can't be added and subtracted together. Okay. All right. Adding, subtracting, easy thing. Nothing major about that. Let's talk about scalar multiplication. Scalar multiplication is kind of like distributive property. Example of that would be taking the number 3 times a matrix. 6, -5, 8, 11, 7, -2. There are no rules as far as the size of the matrix. The dimensions of the matrix do not affect scalar multiplication. Scalar multiplication is just taking a single number and multiplying it to the entire matrix. So every element, for this one, every element gets multiplied by 3. Again, it's one of those things that I normally don't do in the calculator. I'll show you how to do it. But I normally just do that straight, like you would regular arithmetic. I go 3 times 6 is 18. 3 times -5 is -15. 3 times 8 is 24. 3 times 11 is 33. 3 times 7 is 21. 3 times -2 is -6. And I get this matrix that's, what size is that? 3 by 2. 3 rows. Rows first, column second. So this is a 3 by 2 out of that. So scalar multiplication, I generally just do, one element at a time. I don't put it in the calculator. Sometimes you might want to, if they're using some weird numbers or something and you're unsure of what's going on, you can do that. So to put that in the calculator, you just second matrix menu, go to edit, pick a matrix to put it in. I'm going to put it in matrix A. And I have a 3-row by 2-column matrix, and it resizes it for me so that it looks the right way. And then I just put the elements in that I know are there. So I've got 6, -5, 8, 11 is the second row, and the third row is 7, -2. So I'm just putting those individual elements into a 3 by 2 matrix on my calculator. The next thing to do is hit second and mode to get back to the regular calculator screen. And I'm doing scalar multiplication. I'm taking that matrix A that I've typed in there and just multiplying by 3. So if I hit 3, I can hit the times symbol. I don't think you have to, but that's what I'm doing. So I'm just going to do that. And I get the exact same answer that I got by just doing it by hand, which I normally don't do scalar multiplication with the calculator just because it's too easy. And it takes me longer to type the thing in than it would to just do the math. So it's one of those things where, yeah, you can check yourself with it, but it's probably not necessary. Where most people find it useful to be able to do that with the calculator would be when they throw a scalar multiplication problem to you that might have a fraction in it. And, everybody loves fractions. So they're part of the world. So let's do a little bit with them. So again, good number sense. You can just do the math here. 2/3 times 3 would be 2. 2/3 times -5 would be -10/3. 2/3 times 6 would be 4. 2/3 of 6 is 4. 2/3 of 4 would be 8/3. 2/3 of -2 would be -4/3. And then 2/3 of 11 would be 22/3. Now, that's just quick multiplication. Now, not everybody's good with fractions, and I know that. And you know it if you're not good with them too, right? You're well aware of that. So this might be a case where the calculator might be handy to use to do that scalar multiplication. Let's do that one with the calculator, and I want to kind of teach you some of the things that graphing calculator, in order to change our answers back to fractions or get fractions as answers. So I'm going to go to second matrix. I'm going to go to edit, and I'm going to use matrix A again. It really doesn't matter which one you put it in, as long as you remember which one you put it in. And this one is a 2 by 3, so 3, -5, 6, 4, -2, and 11. I'm sure that's the same numbers I'd used. Yeah, it is. And then I'm taking 2/3 times that. So I'm going to hit second and mode to get back to the regular calculator screen. And I'm taking 2/3, 2 divided by 3, times that matrix. So second matrix, and I put mine in matrix A. So that's what I'm going to use. I've got my calculator set to give me decimals as answers first. Because sometimes I taught stats last semester. That's what we needed in there. So that's why it's set that way. You can set your calculator to give you fractions automatically. I usually don't, because there's times where you need a decimal and times where you need a fraction. And it's pretty easy to change this back to a fraction. With the graphing calculator, and if you get a decimal answer and you want a fraction answer, which for me, that's what I want. I want a fraction answer for my class. So you hit the math button, which is third one down there, or fourth one if you count the y equals. It says math on it. Hit math. The first option has an arrow and frac. That means take the answer you got, change it to a fraction. So you just hit enter, and then hit enter again, and it'll convert those into fractions, improper fractions, which is the way we want to leave them. We don't want to do mixed numbers here. Okay? So math enter will change any answer you get from a decimal back to a fraction, if it's possible. You may get a decimal that can't be turned into a fraction because it's like pi or something like that. It can't be turned back into. So math enter turns it into fractions. Okay? And we notice that's the exact same answers that we got by doing it by hand. Okay? All right. Well, let's put that together with what we just talked about with addition and subtraction. Everything builds upon itself. So 2, 4, -1, 1, 0, 2, 7, plus, let's just do a simple one here. So it's making it crazy here. Can I even add those two matrices? And how do I know I can or can't? Yeah, I got to get rid of that 2 thing first. That scalar multiplication. Order of operations still runs things around here. You know, multiplication always comes before addition and subtraction in order of operations. Parentheses always comes first. We always, we're still following those rules. So, like I said, we got to get rid of that 2 first. The reason we know we can add these together is what size is this one? 3 rows by 2 columns. This one is the exact same size. So we know we can do that addition. If you for whatever reason they were being sneaky or whatever and put 2 matrices up there that are not the same size and say add them, even if there is scalar multiplication to do, you can't do that. They have to be the same size in order to do that. So let's go ahead and do our scalar multiplication there. That'd be 8, -2, 2, 0, 4, 14. That's what that one turns into, and we're adding it to this one. And again, you can do this in the calculator if you want. I really don't see the need for it, especially with no fractions in there, anything weird. So, just element for element. 8 plus 8, 16. -2 plus 3, 1. 2 plus -9, -7. 0 plus 5 is 5. 4 plus 3, +7. 14 plus 20, 34. Super easy thing. And we get a 3 by 2 matrix back, which is what we started with. Okay. Not an incredibly difficult thing. Adding, subtracting, scalar multiplication, 2 of the easiest things that we will do all year. So take advantage of that when we're going through them. All right, the next thing that's not hard, and it's directly related to both scalar multiplication and addition and subtraction, are these things called matrix equations. They look like you're rocket scientists when you're doing these, but it's just Algebra 1. Really it is. Let's look at a matrix equation. So this is example G, and here's our matrix equation. 3x, 5, 7, negative 2y. That's our first matrix. It's a 2 by 2. The next matrix needs to be what size in order to add them? 2 by 2. So let's put some numbers in there. 8, negative 2, 4, and 3. And it says matrix equation, so an equation has what in it? And a what sign? Equal signs. Equations have equal signs. So we know it's a matrix equation because it has something that it's equal to. If I were to add a 2 by 2 matrix and a 2 by 2 matrix, I would get a 2 by 2 matrix. That 2 by 2 matrix has some stuff in it. 11, 3, 11, negative 9. Now, that looks really, really complicated, but it's not. Because we know that matrix addition is just taking what? How did they get 11 on that? Yeah, the elements that add up to be 11 are the ones that match up here. So we've got 11 comes from the 8 and the 3x. Because they're all in that first row, first spot. So the equation we're really working with here is 3x plus 8 equals 11. Can we solve that? All right, how do we do it? Subtract 8, we get 3x is equal to 3. Divided by 3, and x is equal to 1. Hey, we got x. What's the equation that would find us this other variable? Negative 2y plus 3 is equal to negative 9. The 2y is here, second row, second column. So I need the elements that are in second row, second column from everybody else. So I set up my equation. Negative 2y plus 3 is equal to negative 9. Subtract 3. Negative 2y is equal to negative 12. Divide by negative 2. Positive 6. Now, I know it's got x and y. That's just the variables I picked. This is not ordered pairs like systems of equations today. These are just, I just happen to use those two variables. That's not a system of equations. That's just two equations that happen to be inside of the matrix. Okay, so those are just solving those individual equations, not solving a system of equations. So I know that's somewhat confusing, but that's what it is. It's not a system of equations. So yeah, it looks tough. It's really easy. Let's look at the next one. Let's make it a little tougher. So we got to be smart. 3 big set of parentheses because I got matrices in there. So I'm gonna put 5x minus 2, 6 minus and negative 4, and then plus 3, 7, negative 5, negative y. Close those parentheses, and then it's going to be equal to negative 21, 15, 3, negative 24. A little bit more difficult problem here, but same idea. What are the elements that go with x? Five x is right there. So what elements in the other matrices go with it? The positive 3 that's there and the negative 21 that's there. What about this 3 out here? What's it do? Yeah, it's a distributed property. It's a scalar multiplier, to what these are when you add them together, right? So when we write our equation, you know, it really doesn't matter that you're multiplying 3 times all these other elements. We only want the ones that go with x to start off with, and then we're going to do the ones with y. So I'm going to set up my equation, 3, and then what would be in the parentheses here? 5x plus 3, and that's equal to negative 21, right? So that element there. So I'm using the 3 that's the scalar multiplier. Everything in here was in parentheses, so that's why I put the 5x and the plus 3 in parentheses. If the parentheses had stopped here, it's a different problem. Okay. We worked that. Several different ways to work that. I'm going to do this. May not be the way you did it, but I bet we get the same answer. I got negative 2. If you distributed the 3 here and did that, that's probably the way most of you would do that, and got 15x plus 9 is equal to negative 21, and then move the 9. That's the way most of us would do that. I saw a shortcut there because I knew 3 went into 21, so that's why I did it that way. Because I know how to divide by 5 a little bit better than I know how to divide by 15, so that's sometimes a shortcut. If this were a number like 20 over here, 3 doesn't go into 20 evenly, so I wouldn't have done that. I'd have distributed and went on from there. So it's just one of those things where, you look for shortcuts when you can find them. That's one of the keys to Algebra 2 is trying to look for some shortcuts when you can get them. What's the equation that we would set up to find y in this problem? Negative 4 plus negative y. All right, so where do I put the times 3? Left side in front of just the negative 4? Just around the 4? Oh, the whole left side gets the parentheses there. All right, so good. And then we do the same things. Can I take that same shortcut on this one that I did over here? 3 and 24. Does 3 go into 24 evenly? Yeah, so you can take that shortcut and keep from having to divide by a larger number. If I divide by 3, that's negative 4 plus negative y is equal to negative 8. Add 4, negative y is negative 4. So what's y? Positive 4. And you can go back to your original problem, the matrix at the beginning, and you can plug those in. Negative 2 times 5, or negative 2 times 5 is negative 10. And negative 10 plus 3 would be negative 7. Negative 7 times 3 is negative 21. It checks out. Negative 4 plus negative 4 is negative 8 times 3 is still negative 24. So we can check those by just plugging in our answers and making sure the matrix added up right. So matching elements is one way that matrix equations can be presented to you. Another way that they could be presented to you is by having a completely missing matrix. So that would be something like this, where we've got a matrix, and we'll just stick with 2 by 2 here because it works the same no matter what size you have. So here we have a matrix plus something else, and we got a matrix back. What does X have to be? A 2 by 2 matrix, right? So all we got to do is think, okay, well, what would I add, because this is a plus sign, what would I add to 3 to get 7? 4. So X is going to be equal to 4 in the first spot. What would I add to negative 2 to get negative 5? Negative 3. What would I add to 5 to get 2? Another negative 3. And then what would I add to 6 to get 11? 5. That's the missing matrix that's in there. Those are fairly simple. We're going to do one that's a little tougher in just a second. But Very simple idea. I think they're less complicated looking than the other ones, but they can make them a little tougher. Like let's do this one. Let's say we had 5, 2, -1, and 6, and let's do plus 3. We'll just use X for the matrix there, and get. Want to end up with 14, 8, -10, and 0. These are a little tougher, but they're similar to the ones we had done before. So we got a 2 by 2 on the left, and we're adding 3 times something else and getting a 2 by 2 back. We know this something else has to be a what? It's a 2 by 2 matrix. Because if you're going to add these together, they got to match up in dimensions. So we know that this has got to be some 2 by 2 matrix, but they did a scalar multiplier by 3 on that matrix to do that. So it's a little tougher to think about, but if you'll just go to the basics of it and think, okay, I can set up 4 equations and solve those and get the 4 pieces, because there's only 4 elements to find, right, on a 2 by 2. To get that first element, the 5 plus what gets me 14. 3 times something gives me 14. Right? Because that scalar multiplier is going to multiply times everybody. And if I solve that, subtract 5, 3a is equal to 9. So a would be 3. So I know x is going to start out with a 3 in the top first row, first column element. Okay. What would be my equation that I would set up to find this spot? 2 plus 3x is equal to 8, or some variable. It doesn't matter what variable you use. I use a or b or x or y or whatever you want to use. So we know that we could set up 2 plus 3 times x is equal to 8. Subtract 2. 3x is equal to 6. We know x is 2. That's what goes in that spot. What's the equation that's going to get us the second row, first spot? Yeah, -1 plus 3x is equal to -10. Add 1. 3x is equal to -9. X is -3. That goes in that spot. One more equation to set up to get that last piece. We've got 6 plus 3x is equal to 0. Subtract 6. X has to be -2. And there is our missing matrix out of that. And again, you can go back and do the scalar multiplication, multiply that sucker by 3, and then add it to the other matrix and make sure it gets you the stuff that's over there on the right. Okay. So matrix equations present in a couple of different ways. One way is you're missing an entire matrix. Another way is you're missing pieces of a matrix out of that. All right, so we've done addition, we've done subtraction, we've done scalar multiplication, and then we've used those and combined those to do matrix equations. Well, the last thing, that operation that we need to talk about is multiplying matrices. Okay, this one is the toughest one. Because there's a lot of operations to multiply 2 matrices together. Multiplying matrices. When you're multiplying 2 matrices together, one of the major differences in multiplying matrices as opposed to multiplying just regular numbers is that matrix multiplication is not commutative. What does that mean? What does it mean for multiplication to be commutative over the regular numbers? Say that again? Not necessarily. What's 2 times 3? What's 3 times 2? That's commutative property. Order doesn't matter when you're multiplying regular numbers. With matrices, order matters. You cannot swap the order and expect to get the same answer back. Okay? So left matrix, right matrix is the idea here. So when you're doing matrix multiplication, you can have a left matrix and a right matrix. And when we're multiplying those two together, you've got rows and columns. So the rows to the left and the columns, and I'm just putting a subscript with an L there. And then on the right matrix, you got rows. So let's put times or by. And then the columns. In order to be legal to do in matrix multiplication, these columns from the left matrix must match the rows from the right matrix. When you write the dimensions like that, left matrix dimension, right matrix dimensions, the numbers in the middle have to match for you to be able to multiply them. Okay, that's what makes that a defined operation. An example of that would be if you had a 2 by 3 matrix times a 3 by 4 matrix. 2 rows, 3 columns, 3 rows, 4 columns. That is legal to be multiplied together because the columns from the left matrix match the rows from the right matrix. Because those two match, that means it's legal. The answer will end up being a 2 by 4. That's where that's coming from. We should be able to discern what size or what dimensions our answer will be if we multiply them together out of that. So we're going to look at multiplying a matrix or two. So this is one of the operations that I do think the calculator is helpful for. Addition, scalar multiplication, subtraction, I don't usually use the calculator to do. Multiplication of matrices, I think it's advantageous to use the calculator for that. If you because I'm going to show you how to do it by hand, and you're going to count up how many operations we got to do. It's a lot. So let's look at a fairly small one. What letter are we on here? K. Let's say we had a matrix 2, -5, 6, 1. Not going to get really crazy numbers here, just going kind of small. And I'm multiplying by 7, 6, 4, -5, 3, 1. What size is the left matrix? 2 by 2. What size is the right matrix? 2 by 3. Is that legal to multiply together? Yes. What size, will our answer be? 2 by 3. 2 rows, 3 columns. All right. Now, here's how it works. You take the row times the column. Just like the dimensions are written, it's row by column. To multiply two matrices together, you're going to match up elements row and column wise. So 2 times 7 plus -5 times -5. Just for the first element of our answer, that's 1, 2, 3 operations to get that one answer. How many elements are in a 2 by 3? 6. So if we're doing 3 operations per element, that's going to give us 18 operations that we've got to do in order to multiply these two together. That's why the calculator is helpful on the matrix multiplication. Because 18 operations, the best of us could make an easy mistake on that, especially when you got positive and negative signs in there, and it adds up, kind of snowballs on you. For the next element, you would take this row times this column. So we're going across the first row of our answer. So it'd be 2 times 6. I'll write that in a different color. 2 times 6 plus negative 5 times 3. And that gets us the second element. Scoot mine over here. More room. And then for the third element in the first row, and we'll take this row times this column. So that'd be 2 times 4 plus negative 5 times 1. Then I do the same thing on the bottom row. To get the first element of the bottom row of my answer, I'd say 6 times 7, 1 times negative 5. Six times 6, 1 times 3. And then the last element is the bottom row times the last column. So 6 times 4 plus 1 times 1. And then I do all that work. So it'd be 14 plus negative 25, which would be negative 11. Right? No, that's positive 25. See, I already made a mistake. 14 plus 25 would be 39 for the first element. The second element would be 12 plus negative 15, which is negative 3. And then we'd have 8 plus negative 5, which is positive 3. And then the bottom row here, we got 6 times 7, that's 42. 1 times negative 5 is negative 5. 42 minus 5 would be 37. And then 36 plus 3 is 39 again. And then the last element, 6 times 4 is 24, plus 1 is 25. And that's just for a 2 by 2 times a 2 by 3. If you had a 3 by 4 times a 4 by 5, it really piles up the number of operations you've got, okay? Because you're going to have number of, your row and your column are going to match up in dimensions, so you're just going to double that every time and then multiply by the number of elements. Sir? Yeah, if these numbers in the middle don't match, it's undefined, just like with the dimensions not matching on addition and subtraction. Yes, that's right. You're not going to see that too much, because the idea is to practice multiplying matrices. Let's do that with the calculator and get that practice done. So calculator, second matrix, I'm going to go to edit, and my matrix A is a 2 by 2, and I'm just putting in 2, negative 5, 6, and 1. So I put in the first matrix, go back to the regular calculator screen, put in my second matrix, go to edit, I'm going to go to matrix B, hit enter. It is a 2 by 3. It has a 7, 6, 4, a negative 5, 3, 4. Once I've put those two matrices in, I'm going to go to my regular calculator screen. So I'm hitting second mode to get there. And then I'm just putting that in. I'm going to go second matrix, matrix A. Make sure you put it in the right order. Left matrix and right matrix. So A is the left matrix. So that's times the right matrix. 2. And we end up with the same answer. I would say for that one, it probably took about the same amount of time to type it in as it would have to do the work. But as the matrices get larger, how long it takes you to get the elements takes longer, and there's a lot more chance of making a mistake. I am absolutely okay with you doing this with the calculator. If you're going to go into engineering, you will take a linear algebra class in which you will have to do this by hand. So if you're planning on being an engineer, it might be good for you to work on doing it by hand, just because you're going to have to when you go to college. So because you're going to take a linear algebra class, or it's going to be something along those lines. Especially if you're an electrical engineer, they use a lot of matrices in that stuff too. So so that would be a useful thing, is being able to do it by hand. But I'm okay with you doing it with a calculator otherwise. Okay, so that's fine with me. Make sure you get the matrix right. On the end of course, a lot of times they'll ask an easy addition or subtraction matrix problem on the non-calculator portion. They usually don't do any multiplication on the non-calculator portion, just because they know how long it takes and how tough it is. So, actually, one of the few things they do right, I think, on that test. So, all right. So here's what you got going on. You got some Khan Academy that's already been assigned to you over all these matrix things. One of those lessons is just tell the dimensions of the matrix. Another lesson is find, it'll ask you for a certain element of that matrix. It's like what row, what column is it in. Get the number that's in that spot. Don't do any work to it. And then there's addition and subtraction and scalar multiplication, and then multiplying matrices. So there's several things, but some of them take very little time. None of this is extremely difficult. Okay, so there's some Khan Academy for you to be working on. You can start on it today. You got about almost 20 minutes left in class, and then tomorrow we'll have a work day over that, and quiz on Monday. We're not snowed out.